Okay, with the session now recorded, can I welcome everyone here to our series tonight. My name is Darren Roberts. I am the current chair of the BCS IRMA Specialist Group. As usual, the IRMA have got a lot of events lined up for you throughout 2021, the first of which today is about measuring control effectiveness with our own treasurer here at the IRMA SG, John Mitchell. Before we about the vital worker campaign that the BCS do, helping to recognise the vital work that the IT community are doing to keeping us all connected. Everyone's pulled together over these last 13 months, specifically with regards to the fantastic work that our health professionals have been doing, not just to keep us all safe, but to help us recover from this dreadful pandemic. However, of course, they wouldn't be able to do a lot of the stuff they would be doing without a lot of the connectivity, the systems, and the work that we do as IT workers. And particularly with regards to us as auditors, making sure that that data remains secure, make sure that data remains validated, and make sure that data remains available and resilient. The BCS have 5 key priorities, which they're following on from this. So do feel free to check those out. Those specifically are about the diverse nature of AI with regards to the ethical workforce going forward, the work that can be done with regards to digital health, support of education of the rigorous and relevant computer science disciplines across the academic spectrum, diversity and inclusion. I myself am the diversity champion here at IRMA SG. And finally, and the one that really appeals to me, is how we link tech and society to overall seek the BCS's aim to make IT good for society. I would encourage you to spend a little bit of time having a look through that web link. As I said, there's lots on there with regards to the fantastic priorities that the BCS are moving towards during 2021. With that in mind, I'd like to hand you over to John, who will take over the rest of the presentation. Thank you, John.
Thank you very much, Darren. Good evening, everyone. My intention this evening is to speak for around about 45 minutes or so. It may overrun a little bit because I tend to get carried away on particular themes as we go through, but I do my best to stick to that timetable, and then there'll be time for questions afterwards. Welcome to this evening, measuring control effectiveness. Well, I've been involved in IT and IT insurance for all my working life, which is quite considerable. And you'll see on the left-hand side, I started off as a data controller. This is not in the sense of GDPR, but literally making sure that the data that should go into the computer actually went into it. Oops, go back. The big challenge in those days was, of course, garbage in, garbage out. I suppose it hasn't changed, but we had this ability to actually control what went in. I then became a computer operator, worked my way through the programming side, became an analyst, eventually a project manager with some very big projects, putting in what were the early networking systems such as KICS. I then became a chief information officer, which was quite interesting. It was whilst I was a CIO that I found out about computer audit, mainly because our external auditors, and I switched careers and became a computer auditor. I then developed into IT governance, sort of the next level up. And for the last 30 years, I've run my own company, which specializes basically in IT governance and risk management. You'll see on the right-hand side, it's the bit at the top, the PhD, which is why we're here today, I guess. When I did my doctorate, I was looking at the use of risk management techniques for audit planning purposes. Now, this was back in the mid to late 1980s. And not many people were doing risk management for business at that particular time. And the reason we're here today is because of this diagram here. You'll notice that on the left-hand side of any arrow, sorry, the right-hand side of any arrow, there's a dot. That's the starting position of a particular risk. You see the risk numbers. And the end point, the arrow at the end, is where the risk ends up after you've got some controls in place. Now, my risk management was really all about this side, actually deciding where were the risky areas in the business. And therefore, I just assumed they're the ones we should actually be auditing. Higher the risk, the more we should look at them from the point of view of control. However, if you think about it today, and this is, remember, I'm back in the 1980s, management is responsible for managing risk, and management is responsible for managing risk via controls. So really, management is responsible for implementing the control set. And our job as auditors is to ensure that those controls are actually effectively managing the risk. So although my PhD was mainly looking at the inherent risk side of it, I was very uncomfortable about how you calculated the residual risk, because you only could calculate the residual risk correctly if you knew how good the controls actually were. And that's our starting position today. It's how good are those controls in managing a particular inherent risk? Does it move it to the desired residual risk that management are wanting? So there's some assumptions we've got to make really from an audit perspective. And it's really quite simple. There are three things an auditor has to know. They have to understand how the control environment works. They have to understand risk management. And they should also be able to define what a control is and how it works. And it's this last bit, what is the control and how it works, which is the main thesis for today's presentation. However, I will quickly look at the first two areas there, the control environment and risk management, because they are linked together. So here is a standard control environment. At the center, I put risk analysis. This is where you decide what risks you have within the business. It's not how you manage them. It's just giving a list of all the risks that exist in the business. And then as you work out from the center of that circle, you see I've got something called risk management. This is once you've done the risk analysis, once you've identified your risk, you then make a decision. Do you live with the risk? Do you tolerate it as it currently stands? Do you try and transfer it to someone else, which is not as easy as it sounds? Do you terminate the risk, eliminate it entirely? Or more likely, you decide to treat the risk. And the way we treat risks is by putting some controls in place, hence control objective, control design, control activity, and control monitoring. So for the rest of this session, they're the areas I'm going to be dealing with. It's going to be the control side in the point of view of managing the inherent risk, assuming we've decided to treat it. If we decide to tolerate it, then we just leave it as it is. There's really nothing to do. But for anything else, we're going to transfer the risk, we're going to terminate the risk, or we're going to treat the risk, then we actually have to do something. But if we decide to tolerate it, we say, well, okay, we've made a management decision. We know it's pretty bad for whatever reason, but we're willing to live with it being pretty bad, either because we can't control it or it's too expensive to control in comparison to what the consequences of the risk crystallizing would be. Now, you see, in order to do this risk management bit that I'm alluding to here, you have to really get to grips with what is a control and how does it work? And then once you know how it works, perhaps you can put some measurement process in place to say how effective is that control. So now here's a standard conundrum for most audit managers. You've got a vast number of risks within the organization, and you've only got limited audit resources. So you probably can't audit everything. And in fact, it could be argued you shouldn't have to, because it's management's responsibility to put the controls in place and then to actually make sure those controls are working. And there's a side issue to this, which of course is control risk self-assessment. If you want management to fully manage the risks, they actually have to understand what a control is and how it operates. Now, if you're going to communicate this to management, then you have to know this yourself. So here's a conundrum for most audit departments. Here I've got 3 risks, and they're all read at the inherent risk level. This is management's decision. Management have looked at these. Management prepares the risk register. Management have said at the inherent level, these are red. These are bad news at the inherent level. The middle column discusses what controls we have in place And the right-hand column is the residual risk, assuming those controls are actually working. So now in risk number one, we have a situation where there are no controls in place, and the residual risk is therefore red, because we're not trying to mitigate that risk in any way whatsoever. And management have accepted that. They know that it's red. I think that's the important thing. Management know they have a problem there. And it's really up to them as to whether they're going to do anything about it. In this case, they've decided they're not going to do anything about it. So it's their choice, their decision. Risk number two, we've got some controls in place, and management think that as a result of those controls, they'll be in the yellow zone. So medium residual risk. We've done some mitigation there, but again, they know that providing those controls are working, it's yellow, and they've decided that's their risk appetite. They're quite willing to live with that risk in the yellow matrix zone, their decision. Risk number three is a fairly typical risk register entry. It's inherent red. There's lots of controls in place, and therefore it becomes residual green, and management breathe a big sigh of relief and saying, well, that's pretty good. We're quite happy with that. And here's the big challenge for the auditor. Which one would you audit? Unfortunately, a lot of auditors do risk number one, the residual risk. Hey, it's red. Surely we as auditors should be doing something about it. I would disagree with that. I would actually say management know it's red. It's their job to do something about it, or it's their job to actually decide they're going to live with it. That, after all, is their risk appetite. Ditto with risk number two, it's yellow, but management know it's yellow. Therefore, it's up to them to either live with it or do something about it. It's risk number three, which is the challenge. It's only green at residual level if those lots of controls are working effectively in managing that risk. And I believe that it's audit's job to give assurance or otherwise that that is the case. Because otherwise we could have a situation where management think, well, that looks like it's green, that's absolutely fine. But in fact, it's not green because those controls are not working, or they're not working effectively. They're not 100% effective in managing that inherent risk from red to green. So my thesis today is we should be looking at risk number three, and more particularly the controls that management have in place that they think gives them a comfortable situation with the green zone in the residual risk. Now you may argue that, and maybe in your organization, audit is tasked with looking at residual risk at red level, and therefore you have to do it because management decided they want you to actually look at that and help them maybe to manage that. But remember, it's not really our job to put in the controls. That's management's job. We recommend that they should have some controls, but they're the experts in their area. They're much better at deciding the controls they actually need, and they're responsible for their operation. We're there to give assurance that those controls are effectively working in managing the risk. Which brings me to my first challenge. What is a control? You ask most auditors and in fact most managers, and they will say, well, they either prevent things happening, or they detect bad things, or they correct them. But that's not the same as saying what a control actually is. That's saying what it does. It does prevent things, it does detect things. It may even react to them and fix things up. But really, a control definition is anything which monitors or modifies the behavior of a system or process to ensure its operational predictability. What we want to know is that if that control is in place and if it's working properly, we can predict what the output should be. So there's the important thing. Really, a control is a test against something where you already know what the answer should be. So I'll give a few examples here. If the gender must be M or F, then we can put a control in place to ensure that it is M or F. So we can monitor the field as it comes into the system. We can do a little test on it. Is it M or F? If it is, that's fine. We're monitoring the system. If it's not M or F, then we can do something about it. So the first bit, monitoring the process, the gender must be M or F. The range must be within 1 to 999, or only numerics are permitted. We know what the result should be, and that's all the thing about a control. Is simply a test where you know what the answer should be. Now, when you have something like a range, you know it must be within that range. It still doesn't make the input correct. Someone inputs 1 when it should be 10, it will be accepted at this particular level because it fits the monitoring criteria. But the test itself is slightly flawed. Therefore, whether it's 1 or 10 or 999, we know it meets the range. We still don't know whether it's correct. And this is the big challenge about measuring controlled effectiveness. How effective that control, if anything, in actually reducing a particular risk. So anything which modifies the system or monitors it is a control. The difference between the two, the monitoring just says it meets the criteria. The modification is where you feel it doesn't fit the criteria and you take some remedial action. So in the case of MRF, if it's not MRF, you probably kick it back to the inputter and say, well, invalid entry. Now we have controls for lots of things, and we have different controls. We have access controls, we have controls for data quality, we have processing controls. Has this passed from one state to another? We have availability. Is the system available to the end user at the appropriate time? And we have compliance controls. This doesn't mean that they don't fit the definition I gave earlier. They all do fit the definition, but they operate in a different manner for each of these things here. But what this means, of course, is for any system that we're looking at, there are going to be hundreds, if not thousands, of controls. And what we need to do is decide what control set has management decided to use, and are these controls therefore working in the way that management intend them to be? And of course, the controls, it may exist within people, it may exist within a process, or it may exist within the technology. In our case, it'll be programming within the systems, for example. And of course, it may be all three of these operating either simultaneously or in a linear fashion. Or sometimes, of course, you have a situation where all the control may be in one area. It may be people only without the technology or processes. So you have to have a mix and a match of these. And it's quite important because I think you see immediately, people are inherently unreliable. You can't rely on a person to do a 100% accurate job 100% of the time. Whereas with technology, you probably can. If it's programmed into the program logic, providing you haven't changed the program, it will do the same thing every time, 100% of the time. So you see immediately the type of control we have in place gives an indication of how much reliance we can put on it. A technological control, providing it's tested, providing we've signed it off, it will occur every time. A people control, probably not 100% effective because they'll be operating some sort of process and they may not do the process as the way it was intended every time. As auditors, we are taught the basic control types almost from nappy stage. We stop bad things happening. If we can't actually stop them at source, we detect them as quickly as possible. And once we've detected the bad thing, we actually put something in place to actually fix it. The last one, we used to call them corrective controls. I think that's actually wrong. I think they're reactive controls. I think that's a much better description. But the reason for the reaction is to fix the bad thing, assuming that we can. So the trouble is with this, with these definitions, there's no granularity. The preventative control either works or it doesn't. It's 100% switched on or it's off. And the same with the detective control and the same with the corrective control. Either you've got it or you haven't. If you've got it, you assume it's 100% effective. And therein lies the challenge, because I hope to show you a little later that it's probably not 100% effective. And therefore you can't be totally reliant on the control. But the basic concept looks pretty good. Stop the bad thing. If you can't stop it, detect it. Once you've detected it, fix it. And that implies a window of opportunity. Yeah, the bad thing has happened. Provided we can fix it within the next 5 minutes, 5 hours, 5 days, the business can still actually carry on. But the other controls either work or they don't work. And that always gave me a bit of a problem, especially when I was doing my PhD. If I was trying to manage a risk, then I was assuming that the controls were actually working. And I had no way of actually establishing whether they were working 100% or 75% or 50% or 25%. The assumption was if they worked, they were 100% effective. Now, here's a typical example of an organization. At the bottom of the graph, we've got the cost of normal business activities. This is running your processes without any controls in place. And you can do that, of course. It's highly risky, of course, but you could do it. But in fact, most management, being a little bit risk adverse, especially senior management, they decide, no, we've got to put something in place so we know whether it's actually operating at all. So they put in a control system. It may be quite simple. Are we actually achieving our business objective? We've got some sort of measure. Business objective is make money. We've got some controls in place so we can look at our expenditure and income, and that decides whether we're making money or not. Now, the total of those two is the total cost of operating your system. Cost of normal business activities plus the cost of the control system is the cost of running your system. Now, if you're revenue generating, you hope that any income will be greater than the sum of those two things. And what I try to show here in this particular slide is we've got a revenue stream there, and it's higher than the total cost of the operating the system, and we call that the surplus. Now, if the system stops working, if the revenue stream is interrupted, and I've shown this as a preventative control failure, then we're in a situation where we still have the cost of our normal business activities, we still have the cost of the control system, we haven't got any income. Now, unless we fix that, we're going to go out of business. And I've got a little bit there showing recovery success, and we carry on as planned. Now, what I've got at the bottom is a thing called detection time, DT, and fix time. And that difference between the two is the recovery time. And at some stage, you or management make a decision. This is the maximum time we can be without that particular service or revenue stream before we're in serious trouble. And what I said there is the difference between the two is, in this case, the best available time we have to fix the problem. At the very end, I've got MT, which is max time. Unless you fix it by then, you're going to go out of business. But what we want to do is to fix it within our specified time window. So we're going to make a decision. The preventive control fails. We detect that it's failed, and we fix it. We react to it. And we try to do that within a particular time window. Now, we can start factoring these into our control mechanism to actually decide what level of control we actually need. But remember, we're still working on the basis of absolute certainty. The control either works or it doesn't. It works 100% or it doesn't. And this was giving me a huge problem in trying to make sense of how good or how bad my controls were. Now, it was quite fortunate that in the early 1990s, Professor David Brewer and William List, who was a partner at KPMG, they looked at this in a little bit more detail. They said, well, we actually think that there are different levels of controlled effectiveness within this very narrow defined band. So what they came up with was a control classification, 1 to 7. And as you see there, we've got a green zone, which is basically prevention and detection controls operating within the desired time frame. And I'll just make a point here. A detective control is really nothing more than a very fast preventative control. You actually have a control failure, the preventative control, the detection control kicks in and fixes the thing immediately. You can do that with computer systems. So invalid gender field MRF, kick it straight back to the user, don't let it go any further, deal with it immediately. But there are some detective controls where you can't actually react quickly enough to fix it within your desired time window. You'll fix it, but you're going to suffer a greater loss while that actually takes place. So this assumes you've actually looked at your processes. You said, okay, I would like it fixed within this period, the fixed time period. However, I'm willing to go out to the max time period, and I can still survive as a business. And then going down 5, 6, and 7, it starts getting a little bit worse because you've got to react to the thing and you're actually running a little bit behind schedule on what is your fixed time. And when you get to level 7, you don't even detect the event and you don't have any business continuity plans in place. And obviously you go out of business. Now, this little table was a great help to me when I was looking at our controls from the point of view of risk management. Okay, this control is not fully preventative, but it does detect it very quickly and it detects it within the time frame that I'm happy with. So I'm willing to live with that. When you get down to 4, 5, and 6, you have to start making a management decision. Can I actually live with that? And with 7, you don't even know it's there, and therefore you've got a major problem. So all of these things up here are actually quite important, but they're not sufficiently granular to really help me, because prevents the event or detects it as it happens, prevents further impact only if the thing works 100%. And there comes the big challenge. I have to say to myself, how can I measure whether I'm getting 100% effectiveness on this control? Because if I'm not, I've got to tell management, hey, that control is only 75% effective. Therefore, you're probably not going into the green zone as you so desire. If we take the control hierarchy, it's all pretty straightforward. What the control is meant to achieve, the control objective. So coming back to my gender, my sex field, the control objective is only M or F will be allowed into the system. How the control will work, well, I'll probably decide that I'm going to have some sort of validation built into it. How does the control work? How does it actually do this? It may be some bit of program logic. And then do I ever look at this again? Do I ever come back and say, well, what's going on here? We've actually changed our business process. Is this control still effectively managing that particular risk? Do I still need it? Does the risk actually exist? So we've got control design, control activity, and control monitoring. So here we are. Here's my example. Only correct sex is accepted is what I'm trying to achieve. My control design is I've got a transaction field and I compare it against my table. My table has 2 entries, M or F. If it goes through that, then I can actually say, okay, I can actually let this go forward to the next stage. And if I run the occasional computer assisted audit technique, if I look for any non-M or F gender fields within the data set, if I've got anything that's not M or F, I know I've got a control failure at some stage. Something's happened in the past, and now maybe I should look at my controls, reevaluate them and say, how the hell did that stuff actually get through the system? On the control design side, I'm absolutely convinced that in the future, you're going to have someone within the organization who is a control designer, because it's a specific and important expertise. And unfortunately, at the moment, we leave it all to management, or they think they're leaving it all to us. But I think there's a skill set involved in actually controlling the design to effectively managing the risk to the management requirement. Which brings me down to what is a control. Well, I've actually broken a control down here into 4 areas. I'm quite grateful to a previous member of IRMA Ross Palmer, who I had many discussions with relating to this, is how can we take a control, break it down into its constituent parts, and then measure how good those parts are actually working. So what I said here, well, we design a control to do something, we implement it into our processes, we monitor whether it's actually working or not, and we reevaluate it to make sure we actually need it. Now at this stage, and before I go any further, I should actually say that all controls are processes, but not all processes are controls. And let me give an example. Imagine yourself, you're a manager, your responsibility is to approve access to IT systems. You're sitting at your desk, and on your left-hand side, you have your in tray, which is the request for access to the system. On your right-hand side, you have an out tray. After you've scrutinized a document from the in tray, you approve it or not, as the case may be, and then you put it into your out tray for the IT guys to actually deal with. So that's a process. You take the document from the in tray, you read the document, you approve it or don't approve it, you put it into the out tray. That's a process. The big challenge is how would someone know that you've actually processed all the requests? Because all you're doing is a process. You turn this into a control. You say, okay, I'll count the number of documents in my in tray. There's 100. And at the end of the day, I'll count the number of documents in my out tray, and there's 100. So you've got to complete this check. It doesn't mean you've actually done anything in the middle. So now we need to put another control in place. Well, yeah, he's processed 100 requests. How do we know that he's actually done the work? Has he actually approved them? And we may then look at all the documents in the output tray for some sort of signature to show you've actually done the work. And then we take those 100 documents and we give them to the IT people and say, right, turn that into your access control list. And when the access control list is completed, they would print out the access control list, and someone else would then compare it to the documents that have been approved by the access control person and say, yeah, okay, we've got 100 people on this access control list. We've got 100 documents saying they should be on there. So now we've got some controls actually in place. Controls are basically looking at something where you know what the answer should be. We had 100 documents in the input tray. We've got 100 documents in the output tray. We've got 100 people on the access control list. So we can actually start then modifying this to say, right, we've got a process and we put some controls over that process. Hence, all controls are processes, but not all processes are controls. Now, if we take an individual control and we look at it from a design point of view, how well should this control work in theory, because at the stage we're only designing it, if it is always applied in the way intended? And I've got a simple mathematical formula, well, not a formula, weighting there. I've numbered things 1 through to 4. I give it a score of 4 if it's designed to reduce the risk aspect entirely, either the likelihood of something happening or the impact if it does happen. If we're talking about preventive controls, we want to reduce the risk of a bad thing going in. So if we think of coming back to our sex, our gender field, we want to reduce the likelihood of an incorrect gender field going into the system. And if I decide I'm going to have some computer programming there, I can design it and say, only let M or F into the system by looking at some sort of table. And I can give that a 4. I know that if I put it into a computer system, it'll work every time. If it's not as good, if there's a doubt that it might not work like that, then maybe a person's going to look at it, and maybe that they'll occasionally make a mistake, that they will let something else through, then maybe I'll score it as a 3, because it's not an automatic process now. It's going to be a human process, and we know that they're not 100% reliable. I may design the control so that the human only looks at every 5th document, because they'd be overwhelmed if they were looking at everything. So I say, okay, we'll score this as a 2. We've designed it to reduce some parts of the risk aspect, but not all of them. We're not looking at every document. And if I've made a mistake in the way I've actually designed it, I've designed it in a way that people might let things easily through that aren't MRF, then I score it as a 1. So what I've basically got here is a very rough mathematical weighting for this element of control design. Now, the important thing here is not my accuracy in actually allocating a number to it, but it means I can have a sensible discussion with management. Do you really think that control manages 100% of that risk aspect? If so, we'll give it a 4. If not, we'll give it a 3 or a 2 or a 1. And the thing is, you have a dialogue with management. I think that's a really important thing, because one of the big challenges I used to find as an auditor was I would go to management and say, your control's not working properly. And they would say, well, basically, what do you mean by that? It's either working or it's not. And I'd argue, well, no, it isn't. Let's actually have a look at what could actually happen. So control design, I score 4, 3, 2, or 1. You can put any number in there that you like. I just find this is nice and simple. What about actually making the control work? Well, here we have a challenge, don't we? Because we're going to put some sort of process in place. If it's a computer program, I've got a bit of program logic in there. I know that that bit of program logic will work every time. The control, MRF, will always be applied. That's the way computer programs work. If I'm not totally reliant on a computer process, if I've got some manual intervention somewhere, then I can't score it as a 4, because I just can't trust human beings and I can't trust them operating the process as intended. So again, rather like with the control design, I will give it a lower score, 3, 2, 1, as we can see there. Again, this is just provide a dialogue with management as to whether their control is working in the way it actually intended. And I can assure you, if it's not within the computer logic, you can't score it as a 4, because we can't rely on 100% effectiveness in that control being applied every time. The next area is the control monitoring. How do we know this control is still working? Well, if it's a bit of program logic and the program has been tested, we can actually monitor it very, very easily. We can just say, okay, every time an MRF field is put into the system, the logic checks it, and if it's not MRF, it kicks it out. So the operation is always monitored by the system. If it's not a computerized process, then we're unlikely to have that sort of reliability, because we know that people might not actually look at everything. They might not actually take the care that we actually would like in this system. So again, we score them 3, 2, or 1 accordingly. And again, you can have the debate with management. And then finally, we have a situation where when this control was invented, when it was designed, when it was implemented, it did a particular job. Now, however, we're a year down the line. The job has changed somewhat. The process may be changed. There's been a change in the regulation, a change in the law. And we have to ask ourselves, is this control still actually needed? And if it is it still effectively managing the risk? We have to reevaluate the thing. And you as auditors will probably know, you go in and you look at an operation, you look at some controls in place, and you say, why have they got that control? And you go to management and they said, well, 5 years ago, audit recommended we should have one. And of course, things have changed in that 5 years, but because audit said you should have this thing, then nothing's actually changed. And again, we score it on 4, 3, 2, or 1. Now, the thing is here, we've now got 4 items, 4 parameters within the anatomy of the control. And for each of those parameters, we've actually got a score of 1, 2, 3, or 4. Now, this allows us to apply a little bit of mathematics. One of these famous algorithms, rather like the likelihood of COVID spreading exponentially through the population. We have the same sort of challenges in designing our systems, our model, as the epidemiologists have. So in this control design example. The objective is only the correct sex is accepted. The risk to the organization is an incorrect sex may be accepted into the system. So the challenge here is you may get M or F into the system, but it may not be the right M or F for the person concerned. And this might be important if you're calculating pension contributions, for example, which until fairly recently were different for men and women because of different retirement ages. You decide this control type is going to be a preventative control. You do not want, under any circumstances, to get anything other than M or F in the system. So we validate it by a bit of program logic. And if it's not M or F, we kick it back to the initiator and say, no, we're not letting this go any further. We've prevented it, a bad thing going into the system, and we've reacted to it, we've detected it, we've sent it back, you do something about it. Now we can actually start, therefore, applying our scoring system to this control. So here we have a situation. The figure in brackets is the highest score you can actually get in each one of these things. So on design, we've got a range of 1 to 4. 4 is the highest. For this particular test, which is the sex field, you see I've only scored it as 3 because I can actually prevent anything other than M or F going into the system, but I can't be absolutely sure that it's the correct M or F, that I've allocated the correct sex to the person. So I can only score it as a 3. I can't possibly score it as a 4 because I don't know whether the initiator, the human being, has made a mistake or not. However, on implementation, because I put this into the program logic, I know it's always going to be working as intended. So I'll score that as a 4. For the monitoring, because there's been a reliance on this computer system always being right, the chances are that the system is, the operation of this control is only monitored on an ad hoc basis. Because why bother monitoring it regularly if the computer's doing its actual job? And on evaluation, I've made an assumption here the control is never reevaluated because nothing's actually changed. It's always going to be M or F. Now we know that, of course, if we think about gender rather than sex, this may not be the case today. And therefore, the fact it's never been reevaluated means the control may no longer be relevant because we're only looking for M or F, where we may be looking for actually, or should be looking for maybe another of other genders. I don't want to get into debate about biological sex versus assigned gender, but it's just something we need to think about from the point of view of, I've never looked at this control since it was implemented, but maybe it's about time I did. Now, here's where the little bit of pseudo mathematics comes into it. The maximum score you could have for this control is 16. You get a maximum of 4 for each of the elements. But in fact, if you look at our scoring, we've only scored 10. We've scored 10 out of 16. So this particular control is only 62% effective in managing whether the correct M or F goes into the system. Now, the thing about this is I'm not going to claim this as being totally accurate, but what I've got here is a discussion for management. Listen, management, the reason it's only 62% in my eyes is because you can never be sure that the M or F you've actually assigned is actually correct for that particular person. Now, you might argue, and not unreasonably, that some of these elements are more important than the others. You might say, hang on, the design and implementation is much, much more important than monitoring or evaluation. And I'll agree with you. So we could apply some sort of weighting factor to this particular control and the elements within it. We could say, hang on, we think the design is 3 times as important as evaluation. But if the design's wrong, then we're going to be off to a bad start anyway. Implementation of the control is 3 times more important than evaluation, because there's no point in designing a control if you don't implement it. So we need to know the control is always applied. Monitoring, we've decided, is twice as important as evaluation, and therefore that would have to be weighted accordingly. So what we now have is a weighting system that actually says design is 3 times as important as evaluation, implementation the same, monitoring is twice as important. We change our scoring accordingly, but surprisingly, it doesn't actually make much difference. We've gone from 62% to 72%. We're still not 100% effective in managing this control. And again, I think this is very important from discussing things with management. Look, management, we agree that design is very important. The implementation is very important. Maybe evaluation is not as important, and we'll accept that. But regardless of what we play around with, we end up with a situation where if you take this control, if you apply our anatomy, design, implementation, monitoring, evaluation, no matter how much you weight the individual elements, it doesn't make much difference to the overall score. So I can sit down with you as management and say, I think that this control is at best only 72% effective in managing whether the person has received the correct gender assignment when the item was put into the system. This enables me to do a number of things, apart from having a good discussion, sensible discussion with management. The first thing is I can look at the risk register with new eyes, and we'll look at that in a moment. I can produce control effectiveness spreadsheets for all the controls relating to a particular risk, for all the risks within a particular system. I can document those controls with my scoring mechanism, and I can actually sit down with management and have a sensible discussion. And more importantly, I can visualize how these controls are actually working via my heat map. So if we take a standard risk register, let's see if I make this can I zoom in? Yes, I can. Okay. Right. If we take the standard risk register, what we have is a risk cause description to actually manage a particular risk. So in this case, inappropriate business solution provided. So this is obviously some development thing. Business processes not aligned with divisions, incorrect or unclear specification. Well, that's a pretty good one. We allocate a risk cause owner, and we calculate an inherent risk score. We say, without any controls in place, this will be in the orange matrix zone. We decide we're going to treat the risk. We're not going to tolerate it. We're not going to try and terminate it. We're going to treat it. We put some controls in place, and we actually describe what those controls are. Now, this is the thing I find about risk registers. I look at these so-called controls, and in many cases, I find they're simply processes. They're not controls at all. They're saying this is what a person does, but it doesn't actually help in preventing, detecting, or reacting to the problem. But over here, management have said, look, we've got these things in place. And as a result of that, we've gone from orange to green. We're quite happy with that risk. What we've got here, of course, is my little scoring system here, because I may disagree with that based upon my risk effectiveness score. And then I can actually insert in here what I think it is. And as a result of that, I can have a sensible discussion with management. So basically, I take their risk register, I look at the individual controls within that risk register for a particular risk, and then I score them. And that gives me something I can actually discuss with them. If we look at my documentation, I have one of these for each risk that I'm actually looking at. Let's zoom in on this. So I look at their particular risk register, and I say, here's the particular risk they've actually got. Here are the controls for managing the risk of incorrect design specification. And as a minimum, it should include these controls. And we've got the controls that management have said they've actually got in place. I do a control classification. Remember, Brewer and lists 1 to 7. I say, okay, this is a preventive control. It's meant to be very fast. I score it as a control class 1. I then ask, does it actually operate? And by that, I look at my control score. My control score, I put into my spreadsheet. I can therefore transfer that to here and say, look, yes, you are doing it, but it's only 72% effective. Then over here, we've got who or what performs the control computer process, how often, every transaction, how is it evidenced, you get some sort of printout or cat. If they actually aren't performing the control, then we actually say, have you got anything alternate to the ones we've actually got up here? Is there something you're actually doing now that you actually haven't documented? And then we can actually go down and look at that particular control and again do the same thing, the control score. Where they haven't got a control in place but they want to put one in, before it actually goes in, we can look at the control, the likely implementation, the likely monitoring, the likely evaluation, and we can generate a potential score for it and say to them, look, before you go ahead and put this in place, do you realize it's only going to be 72% effective? So this is my working paper, if you like. This is my record of me looking at that control to manage a particular risk. More importantly, I actually can go back to management with the evidence of what is actually happening in real life, or what would actually happen in the future if they put a particular control in place. Which of course brings me to the heat map, and you'll see here, this is a typical heat map. We've got the inherent risk and residual risk. Inherent risk is red. We've got the control line. The control line only operates down to green if we reduce both the likelihood and the consequence associated with that risk, which means at a minimum, we're going to need two controls, one to reduce the likelihood, one to reduce the consequence. This did rather upset one of my clients who decided for every risk in the organization, they would have a single control. And I was able to point out to them that didn't quite work, because if you ignored the likelihood reduction, you only went from red to yellow, red to amber, because you weren't reducing the likelihood, you're only reducing the consequence. Likewise, if you don't reduce the consequence, but only reduce the likelihood, again, you go from inherent red to residual yellow. And this is quite important because I can show them using my control documentation which way the arrow goes, and more importantly, the length of the arrow, because the end point of that arrow, where the arrowhead is based on my evaluation of how good the risk, the control actually is in managing the risk. So if it's 72%, then it'll probably only go maybe to the second or third yellow square. Very seldom will it go out to the fourth square to be 100%. This is a genuine risk control visualization from one of my clients. It was the availability of their web service to the end user. And you'll see that three of the risks never even moved out the red zone, despite them having many controls in place. When I looked at the controls, they were not actually managing the risk. So this enabled me to therefore go back to management and say, look, here is, based upon what you've given me, here is my estimate of how well or how badly you're managing the risk. You notice that only 2 of the risks ever go into the green zone. Most of them actually stick in the amber zone. And that's simply because the controls I had in place were either reducing the likelihood or they're reducing the consequence. They weren't actually doing both. And this gave me a very sensible basis for discussion, which actually resulted in the main board agreeing to spend £600,000 to update their business disaster continuity plan. Which brings me, of course, to control documentation. Well, I think they should be, control should be referenced right at the very beginning, right at the requirements, before you've even designed the system. There should be a statement in every requirement specification. The process must be suitably controlled to ensure predictability. You're not saying what it's going to be, that comes down to the design side of it. But the design side, you can say, well, we need data quality rules, confidentiality rules, integrity, availability, and compliance rules. This is why I say in some stage in the future, I think in organizations, you're going to find someone, maybe even the C-suite level, who's going to be the design guru for the organization, the control design guru. And of course, in the testing specification, how will each control actually be tested? So before the thing even goes live, you'll have some idea of whether the controls are actually working effectively or not. But it all goes back really to where you think you're going to end up once you've actually evaluated your controls. So basically, over the years, the control paradigm has changed. And the ones in red here are the big changes that have actually taken place. And as control experts, I guess that's what we're meant to be, we've managed to start dealing with all of these things. We're struggling a little bit with cloud at the moment because control is dispersed in so many different areas. We are beginning to get to grips with it. I suspect expert systems are going to give us another control paradigm change we're going to have to get to grips with at some stage. But whether it's a single batch program or you're dealing with network systems, real-time update, the internet, cloud computing, or expert systems, we have to have some method of measuring control effectiveness. And that's been my thesis for today. I call it pseudo mathematics because it's just made up by me. I suspect there's a PhD in here somewhere for someone, and actually saying, well, actually, Mitchell's thing was a little bit crude. We can actually refine that. Maybe we can actually use machine learning and expert systems to help us make controls better in the future. Just like to end up with one final analogy. You've got 4 aircraft here. Which one would you choose to fly in? Well, the Harrier jump jet has got 1 engine, can only fly on 1. The Eurofighter or the Tornado, the Lightning, the Typhoon has got 2 engines but can fly on 1. The Jumbo 747 there has got 4 engines but can still fly on 1. And the B-52 bomber has got 8 engines, can fly on 2. Now, I know which one I'd prefer to fly in, and that's the one with the most controls. That happens to be the B-52, I guess. If you fly in the Harrier, if the engine flames out, you're pretty much dead. With the Eurofighter, the Typhoon, you can fly on 2 engines, but if one flames out, you can still keep going, so you fly on 1. The Jumbo 747, yeah, it'll lose 3 engines and still keep going. B-52, 8 engines. What they've got are different levels of control, and I prefer the one with the most control. So I go for the 8 engines fly on 2. I can lose 6 engines and still drink my gin and tonic. So I think all the control requirements should form a separate part of the design specification. There should be a section in there which says, these are the data quality rules, these are the process controls, these are the availability controls, and they should be listed and with a definition against them. So data quality must be MRF, must be within this range. We should actually try to calculate how effective they are by using DIME, which gives us a sensible discussion. But I'll end up by just saying most single controls are not 100% effective, which probably means we need more than a single control to manage either the likelihood or the consequence, or we actually decide our risk appetite is sufficient that we can tolerate a 75% effective control. So, okay, now it's back to you guys for questions. Over to you, Darren.
Yeah, thank you, John. That was a really informative presentation there. Can I just say that very recently I've actually taken on a new auditor, a development auditor, and I would strongly recommend, actually, if you've had new members of staff or new people that have joined your practice, to have a consideration of all the things that John said, because a really great introduction to anyone who wants to take part in an IT audit career. So many thanks for that, John. That was excellent. We have no questions at the moment in the chat. Is there anyone who wanted to raise their hand so we can take them off mute? Yep, that's fine. Sergio.
Can you hear me now?
Yes, we can.
Ah, perfect. Sorry, I was on mute. I think I just come back. So yeah, thank you, John, for that presentation. That was really, really good. I have a question, and it's to do with the ratings that you put on the controls. I really enjoy this mathematical relations between risk ratings in general, but I really like how you put forward those controls ratings. And I wonder if you can share with us any of the relations when you calculate the inherent risk rating. So you have a likelihood, you have an impact, and then you just multiply both. How will this controls rating will affect, or what is the relation between this control rating with inherent risk rating? If you can maybe explain a little bit on that, that would be great. Thank you.
Sure. The first thing is I wouldn't multiply the two together. I think that's a fallacious thing to do. I know that it sort of works if you're talking in financial terms, but there's lots of areas where you actually can't multiply things together that well. And even multiplying them together, I think can give a false sense of where the inherent risk actually lies. So I just tend to use the risk matrix and I plot them at the likelihood and consequence level. But I don't tend to do that myself. I tend to let management do that because it's their risk. I can guide them along and say, well, at the inherent level, if this bad thing did happen, what's going to be the impact on the organization and how likely is it to happen? And I say, well, John, it's probably going to happen once every 50 years. But if it did happen, it's going to be a really bad thing for the organization. And then we can actually plot that onto the risk matrix at the inherent level. The big challenge is, of course, is if management decide they're unhappy with that, what are they going to do about it? Well, they will say, we're going to put some controls in place. It may well be they'll try and reduce the likelihood. Well, we might lose the power. So what are we going to do about that? Well, we can prevent losing the power by having the power coming in from two different sources, and there'll be an automatic switch across if we lose one source. And that's fine. They've got some sort of preventative control in place. You say, okay, what happens if you lose your two sources? Then you're in serious trouble. You need a standby generator. So therefore the detection thing kicks in. Standby generator works. So you've got your you've got a distance between prevention control failing and detection control kicking in and doing things. Going back to my original graph, this is the difference between the detect time and the fix time. But my whole thesis has been about deciding whether the controls are effectively managing either the likelihood or the consequence. And I just use figures of 1, 2, 3, or 4 because I wanted to keep it simple. The weightings, I used 3, 3, 2, 1 because I wanted to keep it simple. But I had agreed those with management. Management were quite happy and actually using that. So on that basis, I said to them, you can put any figures you like in there. Let me know what figures you would like in there, and we'll recalculate based on those figures. And we do that on a regular basis, and we still come in within a few percentage points of each other, because it's quite obvious whether the thing's designed correctly or it's implemented correctly. So there's really no great discussion about that. And that actually then, as I said, it provides the movement between the inherent and residual risk, which is the length of the line. And again, I can discuss that with management. They may disagree with me, that's fine. But I want them to actually argue their case as to why they think it's anything different from what I've actually calculated.
Lovely. Thanks, John. We've got 3 more questions coming in from Conrad, David, and Olu. Conrad, do you want to go first, please?
Yeah. Yes, please. Can you hear me? Okay, fine.
Yeah, we can hear you, Conrad.
Yeah. How are you? A question is, I agree with you that keeping the numbers simple is the best way. It doesn't matter whatever you do in risk management, whatever. But when you get down to your red line, there are some circumstances where everyone's in the same boat, so they may not go out of business. Okay, and I take for an example of earthquake in Santiago. I remember going to having a personal presentation with Combank, the clearing bank, and they managed to come back in 4 hours. But they had to bring all the banks into the meeting rooms to survive because they couldn't come back in 2 days. So is it a case where, in your opinion, that even if you go down into your red level or number 7, people stay in business? Because I believe so. If it's an extreme situation where everyone is impacted.
I think, again, it's a management decision, Conrad. It's not really our decision. I mean, I guess we've got an example at the moment with the COVID-19 virus. Everyone's in exactly the same boat.
Yeah.
Some organizations are going to go out of business and some are going to actually muddle through. But from our point of view, as audit and assurance providers, it's not our job to make that decision. We can alert management. We can say, look, your control here is well, you've got no control. You're at level 7. You're at a very high risk of going out of business, but it's up to them to decide whether they want to live with it or not.
Yeah, okay, that's fine. Fair point. Thanks.
Okay, thanks, Conrad. David, over to you.
Can you hear me okay? Yeah.
We can, David. Yes, thank you.
Yeah.
Excellent. So I work in risk management in the aviation industry. And in fact, we do systems, well, we do compliance and auditing systems. So effectively, we're sort of automating some of the things that you have talked about this evening. And so, first of all, can I just say that's been really helpful. It's already crystallized a lot of my thinking that I haven't been able to implement yet because I couldn't grasp it. So you've given me a nice epistemological insight. I think sort of an epistemic shift in my head, which is really helpful. However, what we have got is we've got a system that everybody reports into. So all the audits are reported into it, all the governing documents are reported into it, or any incidents are reported into it. The risk assessment's in there as well. Some of the workflows are managed through that as well. So like if you are doing a pre-flight checklist, you pull up your pre-flight checklist and you go through that as well. So it's all going in. And it feels to me like that could start to automatically generate some of the scores in your dime bar, which is definitely what we should call it, by the way. You know, when it moves, that's the dime bar, right?
Yep.
So did you have any thoughts on that? Because I mean, I think this is quite interesting from my perspective. Equally, I don't want to take all the business away from you.
As I said, there's a PhD in here somewhere.
I'm already doing a PhD
on this. Well, because the areas you're actually touching on need a lot more research.
Okay.
Than I've been able to do. I guess I've provided a very crude framework, and it would be great if we had some sort of expert system that could actually plug in the figures into those attributes automatically from the information that's being received within the organization. Perhaps a bit of machine learning here associated with a proper AI system could then populate what I call my spreadsheets to give the score. Unfortunately, I haven't done the research in that area, and I'm certainly too old to do it now, but I think someone needs to actually do that. And maybe you're the right guy. If you've got all this information coming in, I'm not necessarily suggesting you do a PhD on it, but you could probably add some value to the knowledge base and perhaps actually make it easier in the future for people to exercise their judgment. You see, all the numbers I allocate are just judgmental. Yeah. But then I can have a discussion with management. If we come to the same answer, that's absolutely fine. But if we don't come to the same answer, then their judgmental valuation is just as good or bad as my judgmental valuation. What you're proposing, of course, is that we can put something better into it, and I'd like to go for that.
Yeah.
Perhaps you're the person to do it.
Well, I mean, unfortunately, I'm already doing a PhD in agile narratives, so it's sort of different specialist group, I'm afraid. But there's something there, I think. I was just going to say, the way we're articulating the quality indicator for risk controls is by aggregating the outcomes over time and also having a currency indicator. So it's not a two-value vector. It's a multi-value vector with 2 dimensions. So effectively, on one dimension, we're saying, was the outcome no significant issues? Be cautious, be alert. So sort of classic RAG. But of course, because it's aggregating all of those, you could have 100 green, 3 amber, and a red. And then it's saying, and how recently was the most recent of these carried out? So you've got an indication of the currency of that indicator.
Yep.
And so that's how we're doing it at the moment. But I think that could feed into the DIME matrix. So I think I've got a very busy week ahead of me since this actually goes live on Monday.
Right.
Thank you very much.
That's great. Thank you for that, David. We've got one more question. We got a very short one as well that came up on the chat. Olu, is it? It's over to you. We just unmuted you.
Great, thanks, Darren. Yeah, thanks for the presentation there, John. Quick question, really. What do you think about defining the consequence? Because it can be a bit subjective. What do you think about defining the consequence in terms of actually looking at the cost of the loss? Trying to put some sort of calculation in as far as that's concerned, rather than it be making it more quantifiable and less subjective.
Yeah. I mean, it is a real challenge. Trying to put monetary values on events is very difficult. The insurance industry face this all the time when they're trying to calculate their premiums, because what they're interested in is, what's the likely loss I'm going to be exposed to, and am I collecting enough money to actually pay out on that particular consequence when it crystallizes. And again, I come back to that's really management's job. We can help them, we can guide them, but they have to make the ultimate decision on that. I don't think it's really up to us. But when we think about putting a financial value on loss, you can see how difficult it is if you do it with just loss of life, because various industries put different values on you being dead, even though the result for you is exactly the same, but the actual payout to your dependents will vary very greatly on how you actually die and which industry you're in. If in the nuclear industry, you're apparently valued more highly than if you're in the transport industry. And that's just the way it is. But you know, there are some areas of the business where you can say, okay, if you lose your computing systems, you are totally dead. You know, the actual loss of that is the loss of the business, and that's the total value of the business. So if the value of the business on the stock exchange is 100 million, and suddenly you haven't got a business, then the loss is 100 million. And putting that sort of figure on there quite starkly to management really can actually shake them up a bit. But I come back, you've got to have this discussion with them. You say, look, this is my view, this is my judgment. Now you can disagree with that, and you're quite right to do so. You're the manager, it's ultimately your responsibility, but please just talk me through how you've come to your particular result. So I guess what I would say to you is give it back to them.
Yeah, all right. Thanks, John. Thank you.
Yeah, and thank you, Olu, as well, for asking the question. I was going to ask if there wasn't going to be any questions, so thank you for that. Really, really quickly, John, I know we've gone over time. Kingsley did ask in the chat, what is the difference between controls and security?
Well, actually, security is just a load of controls. If you think of security as confidentiality, integrity, availability, then each one of those elements has a number of controls within it. So security is a control, but it's a vast number of controls. It's not just one control.
Brilliant, thank you. Conrad, a quick 30-seconder, because we've gone over time. Off you go.
You need to unmute. You need to unmute Conrad.
Okay, I come up. Just to back up all what I've done in the past is actually take out the subjective stuff like projects and just go in and find out exactly what your fines are and also what your profits are. For example, in call centers, and basically build it on actual figures. And I will give you an idea, not 100%, but it will give you an idea. Okay.
Brilliant, thank you. Well, once again, I'd like to extend my appreciation to John for a really great session tonight. Don't forget, we've got a series of events happening throughout 2021. So if you are a BCS member, please join our LinkedIn BCS SG group. Search in LinkedIn in the search bar BCS SG, and that will bring up the group. We do check with regards to your BCS membership before you actually are accepted into the group. So as I said, if you are a BCS member, please join us and join us in with some virtual networking with over 200 members. In the meantime, as I said, thank you again to John, and thank you to everyone for the participation here tonight. If you are a BCS member, then this will be available on YouTube for you a little bit later. Thank you very much, and enjoy the rest of your evenings. Thank you.